Hi friends, welcome to the channel Friend for Maths. This is our part 6 video of our chapter 1 real numbers, and in this we are going to do the problems related to revisiting irrational numbers. Okay, I'm going to the first problem, that is to prove that root 5 is a irrational number. In the previous class we have proved root 3 and root 2 are irrational numbers. And in the same way we can prove here root 5 is a irrational number. Okay, and first we are assuming that root 5 is a rational number. That is a wrong assumption. Okay, and if it is a rational number, this root 5 can be written as some r by s form. Okay, and this r and s have some common factor other than 1, and with that common factor we are cancelling r and s, and we are getting some other integers as a and b. And now this a and b have no common factors other than 1, and they are co-prime to each other. Okay, and now we have root 5 is equal to a by b, and that is a is equal to root 5b, and squaring both sides we get a square is equal to the square of root 5 is 5 and b square. Okay, and from this we can know that a square is the multiple of 5. Okay, that is 5 divides a square, and we have a theorem that if 5 divides a square, then 5 divides a also. If 5 divides a, that means 5 is a factor of a. Okay, and now we are taking a as a multiple of 5, that is a is equal to 5k. K is some integer, and substituting this value of a in this equation we get 5k the whole square is equal to 5b square. Okay, we will get 25k square equal to 5b square, and cancelling 5 and 25 we get 5k square equal to b square. And from this we can get that b square is a multiple of 5, that is 5 divides b square, and if 5 divides b square, from the theorem we can know that 5 divides b, that is 5 is a factor of b. And from these two results we get that 5 is a factor of a and b, so they are not co-prime. That means the a and b have a common factor 5 other than 1, so they are not co-prime. But we here we get a false result that the a and b are co-prime. Why we get that? Because of our wrong assumption that root 5 is a rational number. So we can conclude that root 5 is not a rational number and it is a irrational number. Okay. Next question is, prove that 3 plus 2 root 5 is a irrational number. In the same way, first we are assuming that 3 plus 2 root 5 is a rational number. If it is a rational number, we can write it as some r by s, and we are cancelling with the common factor both r and s, and we are getting some a by b, where a and b are now co-prime. Okay, and now we have 3 plus 2 root 5 equal to a by b. And taking this 3 into this side we get 2 root 5 equal to a by b minus 3, and again 2 into this side we get root 5 is equal to 1 by 2 into a by b minus 3. We can know that 1, 2, a, b and 3 are some positive integers, and this will be definitely a rational number. Okay, rational number. If this is a rational number, this root 5 will also be a rational number because they are equal to each other in this result. But we have proved that root 5 is not a rational number, it is a irrational number. So this result will be a wrong result. So why we get this here? That is because of our wrong assumption that 3 plus 2 root 5 is a rational number. So as this is a rational number, and also we have proved that root 5 is a irrational number, we can here conclude that 3 plus 2 root 5 is not a rational number, it is a irrational number. Okay, next we are going to the next problem, that is prove that the following are irrationals. Okay, we can prove all this in the same way. Taking the first one, 1 by root 2. Here we are first assuming that 1 by root 2 is a rational number, and we are writing it as some a by b form, where here a and b are taken as some co-prime integers. Okay, and for the easiness we are taking the reciprocal of this, that is root 2 equal to the reciprocal of a by b, that is b by a. Okay, and we can know that b and a are some positive integers, and definitely this b by a will be a rational number. Okay, if b by a is a rational number, if then this root 2 will be also a rational number. But we have proved that root 2 is a irrational number, isn't it? So this is a wrong result, that is they are equal to each other, that is a wrong result. That is because of our wrong assumption that 1 by root 2 is a rational number. So we can conclude that 1 by root 2 is not a rational number and it is a irrational number. Okay, next is 7 root 5. In the same way we are assuming first as 7 root 5 is a rational number, and as it is a rational number we can write it as 7 root 5 is equal to some a by b form, that is a and b are taken as some co-prime integers, and here 7 root 5 equal to a by b, and 7 taking to this side we get root 5 is equal to a by 7b, and here a, 7 and b are some positive integers, and definitely a by 7b will be a rational number. If this is a rational number, this root 5 will also be a rational number, but we have proved that root 5 is not a rational number, it is a irrational number. So this result here is a wrong. Okay, that is because of our wrong assumption that 7 root 5 is a rational number. So we can conclude that 7 root 5 is not a rational number, it is a irrational number. Okay, going to the last one, 6 plus root 2 is a irrational number. We have to prove. Okay, and taking it as a rational number, that is we are assuming that 6 plus root 2 be a rational number, and if it is a rational number we can write it as in the form a by b, and we are taking a and b here as some co-prime integers. Okay, and here 6 plus root 2 is equal to a by b, and here taking 6 into this side we get root 2 is equal to a by b minus 6. Okay, and a, b, 6 are some positive integers, and we can know that a by b minus 6 is will be definitely a rational number. If this is a rational number, then this root 2 will also be a rational number, but we have proved that root 2 is not a rational number, it is a irrational number. So this is a rational number. So we can conclude that this 6 plus root 2 is not a rational number, it is a irrational number. Okay, we can stop here now, and if you like this channel, please subscribe the channel and share with your friends, and see you in the next video. If you have any suggestions and doubts, you can mail me at friend4maths@gmail.com. Okay, till then, take care, bye.